Hello dear students, I heartily welcome you in our video lecture series on subject Structure Analysis 1. So as you know, in this series we were discussing on module 3 fixed beam. So we will continue this series. So in this today's lecture number 4 we will continue our discussion on analysis of propped cantilever beam. So objective of this lecture is that after completion of this lecture you would be able to solve the prop reaction of a propped cantilever beam. You can able to construct shear force and bending moment diagram for propped cantilevers, and also can able to mark point of contraflexure and can understand what is point of contraflexure. Okay, so let's recap first what we have learned in previous sessions. So we have learned that in case of propped cantilever, to calculate the additional reaction, the deflection due to external loading is equated to the deflection due to the prop. And also study the problem, and we were able now to draw loading diagram for the given conditions of the numerical, and also can able to draw shear force and bending moment diagram for propped cantilever, which we have learned in previous session. So in this session we will solve a problem in which we will deal with the Udl loading or type of load on the beam as Udl, and also will able to know about point of contraflexure and will mark point of contraflexure on the bending moment diagram. So here there is a numerical on your screen. A cantilever AB 6 meter long carries a point load of 15 kN at the free end, and this beam is propped at C, where there is no deflection at 4 meter from the fixed end. So in this numerical, free end is not propped. The propped support is provided at a distance of 4 meter from the fixed end, that is in between free end to fixed end. And at this propped, it has said that there is no deflection. Now find the reaction of the prop and also construct shear force and bending moment diagram and mark point of contraflexure. So first of all, let's draw the loading diagram based on the data. So in numerical it has given that there is a AB cantilever beam of 6 meter span, 4 plus 3 6 meter, and at 4 meter from A, that is at point C, there is a prop, and also at free end it is subjected to point load of 15 kN. So this P is a prop reaction, A is fixed end. Okay, now tell me the given data based on the numerical. Yes, span of the beam is given as 6 meter, load on the beam is 15 kN, which is acting at the free end, and prop is provided at distance of 4 meter from the fixed end. This is the given. Now as we know, to find propped reaction we have to equate downward deflection due to point load with the upward deflection due to the prop. So in this case, downward deflection caused by only load 15 kN without prop at any distance x from A will be calculated with the help of differential equation. So in previous numericals we have deal with the problems where free end is propped and load is provided in between the free end and fixed end, okay, or propped end or fixed end. For that we know the formula. Now in this case, first we have to derive the formula based on the differential equation or basic principle. So we know that differential equation for the deflection is EI into d2y by dx square equals to minus m. Okay, Now you can see the diagram. That is, this section is at a distance of x from the fixed end. Now we have to find moment at this distance x from the fixed end A, that is mx, and we will differentiate it to get deflection. Okay, so as we know, mx can be obtained as, we have to take moment from this. How to find? Can anybody tell? In first case, we are considering there is a cantilever which is subjected to point load at free end only. There is no prop is considered. Okay, so ignore this prop and just take moment of this 15 kilonewton load from the section. Now tell me, this section is at a distance of x from A. What will be the moment at distance x from A, that is mx? Yes, mx will be 15 into this distance, that is span minus this x, or we can write it 6 minus x. Now here we have taken as a clockwise, or just write to this section moment clockwise as a negative, hence mx will be minus 15 times 6 minus x. This will be the moment at distance x from support A. Now we will put in our basic equation, ei into dt by dx square will be equals to minus of minus 15 into 6 minus x. Let it be equation 1. Now let's derivate it. So before derivation, simplify. We will simplify it as a 15 into 6 minus x, minus minus will get cancelled, or it will become 90 minus 15x. Okay, so let's integrate it with respect to x. The above equation 1, we will get ei dy by dx equals to 90x minus 15 into x square by 2 plus c1. c1 will be the constant of integration. Okay, now to find this constant, let's consider support condition. So at a distance x equals to 0, section will be at fixed end. Section will be at fixed end, where we know that slope dy by dx equals to 0. If we put x equals to 0, dy by dx equals to 0, then the c will become 0. Okay, now let's integrate this equation again with respect to x. We will get ei into y into 90x square by 2 minus 15x cube by 3 into 2 means 6. Now as c1 is 0, again here there is a second constant of integration, that is c2. Now to find the c2, again we will consider the support condition at x equals to 0. Now tell me, at x equals to 0, we said that slope is 0. What about deflection? Can anybody answer? Yes, at support x equals to 0, deflection is also 0 due to fixity of the support. Hence, by putting these values in this equation, we will get c2 equals to 0. Now here we have found these two constant of integration, and our simplified equation of deflection will be ei into y is equals to 90 into x square by 2 minus 15x cube by 6. Likewise. Okay, this is our deflection equation. Now to find deflection at any point, we will just put the value of x, or distance of that section from the fixed end, then we will get deflection at that point. Now to find downward deflection at C due to the point load alone, now we can calculate it by just putting the value of x equals to 4. We know that the C is at a distance of 4 meter from the fixed end, that is propped support. Therefore yc will be equals to 90 into x is 4 square by 2 minus 15 into x cube, x is 4 cube by 6, this bracket multiply by 1 by ei. This ei will become here in dividation on the other side. Now by solving this and by simplifying, we will get yc equals to 560 by EI. Try to solve it by your own. Solve and compare your answer. Everyone, you got this answer? Okay, yc equals to 560 divided by EI. Now this is the deflection at C due to the point load. Now what about deflection at C due to the upward prop? Now this deflection can also found by method of area or moment area method, which we have already discussed in unit 1, that is slope and deflection module. Now as since there is no deflection at point C, then therefore downward deflection at C, this downward deflection at C will be equals to the upward deflection by the prop alone at C. Okay, so let's calculate upward deflection due to the prop at C. How to find? Now we know the formula. Let's consider only distance of cantilever up to the prop, that is at a distance of 4 meter. That is in between A to C, we will consider this portion only. So क्या कंसिडर करेंगे हम? सपोर्ट A से C तक का डिस्टेंस कंसिडर करेंगे और C पर हमने सपोर्ट अप्लाई करे हुआ है, प्रॉप कैंटिलीवर और प्रॉप सपोर्ट. वी नो ड्यू टू दिस प्रॉप the upward deflection will be WL cube divided by 3ER. Here W is nothing but reaction of prop, that is P, and L the distance between A to C, in this case 4 cube divided by 3ER. Now by solving we will get 64P divided by 3ER. Now this is the upward deflection at point C due to the prop only. Now by equating these two, 560 by EI equals to 64P divided by 3EI. EI will get cancelled, and by simplifying we will get P as a 26.25, or we can say the reaction of prop equals to 26.25 kilonewton. Got it? Note it down fast. So likewise, from basic principle you can find deflection and you can equate and will calculate. So today we will stop here in this part 1. We will continue this numerical in part 2 of this lecture.